Okay, just want to welcome everyone to the Institute of Mechanical Engineers Railway Division Young Members Future of Rail Competition Final. That's the hardest part of the introduction over with. So firstly, you'll have to bear with us for the new format. We do have an agenda for the evening, which I'll run through shortly. We'll do our best to stick to this agenda, but your flexibility and patience will be appreciated throughout the evening. Whilst there are some benefits to lockdown, like only having to wind the front of my shirt and from the chest up, it's a shame we can't be at one birdcage walk today, because it really does set the scene for this kind of presentation, but hopefully we'll be returning next time. This does bring a few benefits, however, because we don't have to limit the numbers, and we're expecting quite a large audience tonight, so thank you to everyone for joining us. We've got some fantastic presentations for you. All of them have earned the right to be here, some fantastic presentations, and to get to the finals, each presenter has had to win their own regional heat, which has been independently organised by the regional chairs of the IMechE RDYM, with helps from volunteers along the way on the judging panels. So I believe we owe a quick thank to the regions for providing us for worthy finalists. And now to the judges for tonight. We've pulled out the big guns. We've got the current chair and vice chair of the IMechE Railway Division Young Members, Mayanne Liu and David Pearce, respectively. The current chair of the IMechE Railway Division, Felix Schmidt. And our special guest judge will be Kuldeep Garataya. Anyone who's involved with the IMechE would likely know these people, and so thank you for volunteering to be on the judges panel. We're also honoured to have the outgoing chair of the IMechE Railway Division, Graham Neal. Graham will spend some time to present his report for the AGM during the judges' deliberation. After Graham, we'll also have a few words from the second vice chair of the RDYM, Paul Burkett-Gray, who's going to be talking about some RDYM events. So a quick outline for the evening. Presentations will start shortly after this introduction, scheduled for 17:35. Each presentation will be 10 minutes long and will allow 5 minutes for questions afterwards. Judges will be the first to ask any questions, and we're hoping there'll be a short space of time for 1 or 2 questions from the audience as well. If you could message these to me in the chat, I'll try and pick these out. There'll be a break after the first four presentations about 18:35 for 10 minutes, and we'll resume again at 18:45. Last presentation should end about 19:30, where the judges will break for deliberation, and we will have Graham and Paul. At this point, we'll hand over to Felix Schmidt, who will present the findings and also announce the winner, and then we'll close the event. So just a quick mention to Emma from the IMechE, who's going to be running this and driving this off driving the WebEx. So thank you for doing that for us. And without further ado, I'm going to pass you straight to Sarah Cressy for the first presentation on digital maintenance.
Good evening, everyone. My name's Sarah Cressy. I am a systems engineer currently working at Hitachi Rail, and my role within Hitachi Rail is as part of a team focusing on the introduction of new and emerging technologies into the business. This evening, I am going to give you an exciting introduction into the world of digital maintenance. So to start with, I'm going to share my own story of how I was introduced to this delightful world. And I made the very grave error of saying that I needed a new challenge. So I was brought into a meeting room full of data scientists to provide them with the knowledge of how a train physically functions. So the first experience was all these data scientists excitedly scribbling down on a flip chart, and then the comment was made, well, it's easy to see which algorithm you would use here. To which I was like, no, it most certainly is not. So how can we hope to achieve anything as an industry when we have polar opposites of expertise? The answer is people. So I recently attended a conference in which someone stated that data scientists should be the most in demand, the most important people to drag the railway industry into the digital age. Well, I disagree. A data scientist could come to me and excitedly give me this rule, which, because they have no knowledge of the actual trains, operations, and legislations, would be mostly incorrect and probably impractical. So what we need to do is create a new hybrid breed of systems engineers mixed with data scientists. And this is what I am currently trying to work towards as part of my own development. But where do we even start with this? Well, everything begins with data. Data is everywhere. We collect masses and masses and masses of data from our trains every hour of every day. We store it all up nice and neat and safe, and we feel content within ourselves that we're meeting the demands of the customer because we merely have all this data that can help us in our mission. But what does this data actually tell us? Well, nothing, because we need to turn this data into information. It's only then that we can use it for practical applications. This sounds simple. Well, not necessarily. So let me give you an example. So we effectively have two groups, the puppies and the pooches. We've picked our breed of puppy for certain traits. The puppies are super, super cute, young, excitable, reliable, if a little bit mischievous at times, and capable of providing us with vast amounts of data. Everyone loves the puppies, much like our flashy new Hitachi IEPs. However, we haven't had our puppies very long, so we don't really know what all this data that they're giving us really means. So you would think the problem would be solved by a pooch. It's older, it's set in its ways, we know how she behaves, quirks and everything. We have lots and lots and lots and lots of information to help us with our pooch. But our pooch came from a time when they didn't really know the value of the data which sits behind the information. So we have no way to know what information is coming without teaching it some new tricks, much like our legacy fleets within the UK. So I'm going to start with the pooches. The railway system in Great Britain is the oldest in the world, with the first loco-hauled public railway being opened in 1825, and it seems like a lot of our rolling stock comes from that time. These legacy fleets, while slowly being replaced, still form a massive part of the day-to-day running of the British Railway. So we need to think of how best we can introduce digital maintenance on these. Whilst it's very old technology in some of our legacy fleets, there are many products which can now be retrofitted to help us in our mission. In some ways, it can actually prove as an advantage over the newer fleets. Why is this? Well, because all the background work and justifications are done prior to the system being retrofitted. The data we're getting off, we already know how to turn that data into information. This has a further benefit that because we're not taking more data off the train via 3 or 4G than we actually need, we're not paying extra costs for data transfer. If the designated system being installed from an external supplier, then it's likely to have a wider breadth of experience from different fleets that we can then benefit from via the already proved and accurate algorithms. This process generally tends to be more focused and in a lot of ways more streamlined. For the new fleets, we are drowning. We are drowning in a lake of data. We are like kids in a candy shop. There is so much choice that all we are managing to do is make ourselves sick. And because we haven't had the trains for that long, we're still in the process of understanding how to turn any of that data into useful and usable information. Algorithm development, which is what we require for us to predict maintenance on condition, follows a pattern. It starts with data analysis, in which we need in-depth system knowledge to help us identify what is typically normal and typically fault behaviors. We then propose a rule, we then prove said rule, and then it's followed by extensive trials. Now, despite this lake of data that we're drowning in, sometimes it happens that we don't have enough of suitable data for the time period to allow these algorithms to be as accurate as we would like. We also need to take into account that the rail network is still not fully set up for data transfer, with a lack of things like Wi-Fi and also signal black spots providing barriers to fully digital implementation. But it's not all negatives and misery. There's lots of good progress being made. This is largely through taking the time to fully understand the limitations and their effects. All the information and knowledge that we are gaining can also be fed into future train design so we can improve even further going forwards. So what is the ultimate aim? Well, much more can be gained from the data through production of a digital twin, or in this case, a digital train. So what we do is we take all the signals from the train and map them digitally as an exact copy of the physical unit. What this does is provides us with a massive step forwards in our understanding and turning all that data into this sought after information. Whilst this is best done at the design phase, it can also be retrospectively achieved. So, in summary, we've come a long way from the era of the choo-choo trains. We can now all sit there and pretend like NASA and fault find remotely. But that doesn't mean that we've necessarily solved all our problems yet. Personally, I am very excited for the day when the Azuma becomes the legacy fleet for us and what that future has in store for us. Thank you for your attention.
Thank you there for the presentation, Sarah. I think that's a very good presentation on, and especially data sciences and bridging the gap between engineering. I think that's very relevant in today's environment. So over to the judges for any questions.
Okay, Felix, question. Can you give a very simple example of the type of information which you have already managed to extract from the IEPs?
So one of our main projects has been in calculation of pantograph carbon wear. So this is taking some typically like old school, whatever you want to call it, maintenance tasks, and then using the information coming from that as well as from the trains to inform when the carbons need replacing.
Thank you.
Kuldeep here. Sarah, fantastic presentation. Thank you. Topic dear to my heart. I also agree that data scientists alone can't solve the problems. We get a lot of them. They do a lot of work and they turn up and they say, did you know it gets busy in the morning and busy in the evening? And as you can imagine, for an engineer, that can be quite frustrating. So you're talking about creating this hybrid role, but what I sort of can see is that contextual knowledge of the engineer is really important to solving these problems. How do you drive that accessibility to the data and that availability down to the lowest level, like the shop floor? Because they obviously can see patterns that it may take others months or weeks to see.
So from the team that I currently sit in, I am the engineer, and we have a lovely lady who is one of the data scientists. And what we do is when we go through developing an algorithm, at the moment, we don't even start with the data. We start with people like the shop floor, the shift engineers, the guru systems engineers that only deal with one systems. And we say to them, either, what problem have you got? We can solve it. Or have you noticed something? We can look into it and tell you if you're like, yay, or you're talking whatever. And that's how we're tending to start, because we know that that is going to be useful, rather than us analysing data merrily going, oh, this is really good. And the business goes, yeah, but we don't want that. So for me, it starts with the shop floor and the systems engineers.
That's brilliant. And does it end there as well? So there is no other team? They're just doing that work themselves?
Do you mean my team or the engineering team, sorry?
Yeah, how do you do yourself out of a job? Because if they've got access to data, they can sort of see those patterns and get on with it. Will that happen?
Maybe by the time I retire. So I'm not going to do myself out of a job, maybe future like engineers. But what we're trying to do is actually empower engineers and stuff to do it themselves, because one, we're quite a small team within Hitachi at the moment, so we don't want to be doing it all. And they can provide a lot of stuff, and if we just say yes, that's fine, they can do it. There's so many things, so much opportunity to do. Why would we limit it and keep it selfishly to ourselves when we can open it up to the engineers and teach them to do it as well? So for me, it might be doing myself out of a job, but it's like in a good way. So I don't think that's a bad thing.
Good answer. Thank you.
Okay, we've got a few more minutes. If there's any more judges' questions.
No.
Okay, I can't see any questions from the virtual audience at the moment.
Stuart, I do have one
Okay.
short question.
Sorry.
Right, it took me a while to unmute myself. Sarah, I like that you say you're developing yourself towards that goal of a hybrid, and I think that going in the future, that is a very important skill to have. But so far, the education system, or maybe in the UK, for example, in railway courses, it's still very much, well, I've graduated a long time ago now, so I don't know what the latest railway courses are like, but I assume it hasn't really moved much. And does it actually provide this new generation of hybrid engineers, data scientists? Do you have any comments on that, and how do you think we can improve that going forward?
So I would tend to agree with you. I don't really. It was a little bit of time since I graduated, and I didn't do a rail specific degree. But it doesn't really come out of university or however people enter the industry. So how we approach it within Hitachi is if someone comes in our team, they learn everything. And then they pick whether they want to be a data scientist that is a bit of a systems engineer, or a systems engineer that is a bit of a data scientist, and that kind of hybrid and stuff like that. So I would say that we can't even have a hope in putting it into education, universities, like apprenticeships and stuff like that, until we have a good enough understanding of how we are developing ourselves that are already in the industry. Because I think we're best placed to say this is the easiest way forward, because if we start trying to do it too soon, people are going to get insanely frustrated, and it's going to put people off a career doing something like this. So I think we need to get ourselves set up and have some good, like, look how good we are examples, and an efficient way to get people to this point before we start pushing it back into the education system.
Thank you.
Okay, we might have time for one quick question from the audience. I've just spotted. It's from a familiar name. Mark Molyneux has asked, how long does it take to develop a reliable algorithm?
Depends on the algorithm, how much you've got, like data going backwards and stuff like that. But they say like 2 or 3 years worth of data at least. And then you've got testing in service to make sure it's not giving us any false positives and bits and pieces like that.
Okay. Thank you very much, Sarah, for your answers. Brilliantly answered there. So if we move on to the next presenter, this will be Amanda Suter, and she'll be talking ESR technology, in-service monitoring of Centrebush.
Hi there. So as just introduced, I'm Amanda, and today I'll be talking to you about in-service monitoring of a centre pivot bush. So a centre pivot bush is a rubber element that's designed to absorb shock and vibration between the track and the carriage of the train. So the problem is that it's failing early in life, which causes a loud knocking sound, which, for anyone riding the train, is very unpleasant. It's not a safety critical component, but it is very unpleasant when it's banging very loudly underneath the train. It's failing through rubber fatigue, so the rubber element is failing first. ESR technology have carried out accelerated life testing in the lab, and part of the purpose of this project is to validate the accelerated life testing of the bush itself, but also to provide correct parameters for a redesign of the bush. So this is what it looks like when it's cut in half. you can see where it's failing in the rubber element, and when that element goes, you get a metal and metal contact, causing a loud banging. So this is what it looks like. On the left, you can see I've got the casting and the pivot drawn, and the casting is attached to the undercarriage, the bogie of the train, via 2 tie bars. This allows it to move in 6 degrees of freedom, and you can't see my mouse pointing here, but it's the center pivot bush is between the casting and the pivot. So on the left here, you can see a little diagram, hopefully, that is what 6 degrees of freedom look like. So it can move up and down, left, right, forward and back, pitch, roll, and twist as well. So I created a mathematical model that allowed me to determine where to place sensors so I could work out what the bush is doing in each degree of freedom. The sensors I used were draw wires. So a draw wire, when you pull the wire, it gives you a voltage output, which you can translate into a distance measurement. So for this testing, I used a NextView 4 software. I used 6 draw wires through my matrix to determine the 6 degrees of freedom. I used 2 3-axis accelerometers, 2 strain gauge rosettes, amplifiers, and I used power packs and added 25 meters of cabling that ran from underneath the train, up the side of the train, and in through the driver's door where I had all my data collection instruments. I was then able to Wi-Fi in from the carriage on a laptop so that I could check all this while it was running. The next problem I had was actually fitting it onto the train. So I designed this plate which could be removed easily afterwards so that I could turn up on the day of fitting, place the sensors on the plate onto the casting and fit it onto the train so that it was easy all just to go. One of the main problems though, as you can see from these pictures here, is that there is very limited space. So it was really important that none of these wires fouled on any of the parts underneath the train as it was all moving about in all random directions. At the time of designing this, we didn't know what these directions were doing exactly because that's the purpose of this testing. So it had to be very, very careful not to do it. And you can even see I've used a little pulley system there to get the wires orientated in the correct direction for the model. Oh, that's the wrong button. So this is you can see the 3-axis accelerometers in the middle there and the 2 wires on the bottom as well. I fitted the strain gauges in the lab so that again they would just be easy to put onto the train. And you can see here I've got the cabling running from underneath the train up along the side, and on the right hand side you can see where I've got my power packs and my data acquisition equipment. So on the actual test day we managed to get 13 hours of data on 18 different channels. That's quite a lot of data to access and analyze. So from this I was able to get the acceleration and the strain. I was able to identify the 6 degrees of freedom through my matrix setup, which I had to run through Octave. Excel wouldn't cut this, there was far too much data. I was able to get speed and displacement from a GPS sensor that I had with me on the train, and I also carried out a rainflow analysis on this. So the data we got was good. Here I've got a table that shows the minimum and the maximum movement in each direction, and I've got the range. So in the X direction, I've got a range of about 9.5 millimeters, got a pitch and roll about 10, 11 degrees, and I've got a yaw, so the twisting movement, of about 6.4 degrees. So here you should be able to see 7 graphs. I've put this in here just to show you how good this data was. So this is a snapshot over accelerating around a corner. I did previously have a picture in here that showed the actual route that the train was taking at the time. However, I had to take that out because then you'd be able to tell exactly what train it was on. So at the bottom, highlighted in red, you've got the speed with time. And at the top, you've got the movement in the X direction. So you can see clearly here, as the train is at a stop, there's no movement in the X direction. But as it starts to accelerate, and slow down or level out in speed and then speed up again, you can clearly see the movement in the X direction. And here I've highlighted the twisting movement. Again, with the other picture it would clearly show, but as it's coming around the corner, it turns, and then as it turns back round onto the straight, it levels out. So again, just good data. And we were able to snapshot this data over any point over the 13 hours. So what was the information I managed to get? I managed to get the largest linear and angular displacements occurred in the direction of travel. The most damaging displacements occurred during off-peak journeys. The largest X, Y, and yaw displacements occurred during off-peak travel on a bend. This is mostly due to the acceleration of the train being faster. The largest pitch angles occurred during on-peak travel due to a higher torque. The number of cycles larger than 7.5 millimeters in a single axis per year is 10,187. From this, I was able to say that cracking initiation is likely to start in 1 year of service. And I can also say that from the displacements we've seen, the laboratory test conditions for the testing of the bushes provides a good basis for comparison. So the overview of the work I've completed: I created the mathematical model, I designed all the fixings, I fitted all of the instrumentation and calibrated it, and I did the data collection, and I also did the post-data collection analysis. Oh, that's the wrong way again, sorry. Any questions?
Thank you very much, Amanda. Very detailed and thorough presentation there. Interesting subject matter also. So we'll go straight on to the judges panel for questions.
So I've got a question, Stuart. It's David Highlander. Great presentation. I suppose a slightly selfish question here from from my particular standpoint. Obviously, with the work you've done, you will have had to have a lot of interface with the operators of the vehicles.
Yes.
How did you go about managing the relationship with them and assuring them that this kit was safe? Because a lot of operators can be a bit touchy about putting things on you, I'm afraid.
Yeah, of course. So there was a lot of preparation gone into this. So we made sure that everything had secondary retention for a start. Nothing was left to one mode of attachment. And we did a lot of talks with them. We prepared documents and evidence as to why what we were doing was going to be safe.
Lovely, thank you.
Felix, just quick question. Is this life of 1 year actually something which is really appalling, or is it something which is just about okay, or is it even better than that?
So I believe they're supposed to last 5 years. So 1 year failing from new is quite bad.
Thank you.
Okay, if there's no more.
I was going to say, brilliant, really good presentation. If you had not gone for a physical fitment and modelled this based on what you knew or what you thought you knew using FEA or whatever it may be, how close do you think you would have got to that answer?
See, I'm not sure we would have got at all, to be honest. A lot of the problem with that is you're assuming parameters, and the original bush was designed to parameters that they thought they knew.
Mm.
So the problem came in where the parameters they thought they had weren't necessarily realistic, and we needed to check that and verify it.
Sure. And did you go back and look at their modelling principles?
To be honest, it wasn't actually available. It was designed so long ago that the information was lost.
Okay, thank you.
So we've actually we've received the new bushes today to do the next bunch of accelerated life test on them. So hopefully these ones work.
Yeah, brilliant. Good luck.
Thanks.
Okay, so we've got a few questions from the audience. I'll start from the top. Gareth Tucker. You have to bear with me, scrolling is a bit difficult on here. So I was very interested in your presentation. I work at the Institute of Railway Research in the University of Huddersfield.
Sorry, Stuart, I think the Gareth one is for Sarah's presentation. So if you go down to
I missed those. Apologies. Yeah. So yeah. Oh, there we go. This one from Amanda from Rebecca Selleck. I'm wondering what happens next with your project. Will it change design and maintenance?
Yes. So sorry, I've just answered that a little bit. The bushes have been sent out for redesign with these new parameters, and they've been redesigned, and we've now got them at the lab again to start testing on them for the accelerated life test to see if these do any better.
Okay, we do have another one as well from Andy Batters. Were you able to identify the failure of the bush, i.e. the rubber itself, or the bonding between the rubber and steel?
So it was cracking of the rubber itself. If I can, don't know if I can go back on here, but there was a picture right at the start. So you could, when we split it in half, we split it with liquid nitrogen. So you could see the darker element in the rubber was where it was the original tear, and then it was the lighter area was from the liquid nitrogen. You could see from the cracking in the rubber that it was actually fatigue of the rubber element.
Okay, we've got about 30 seconds left. I'll just ask this one. You might not have time to answer it. Louise Shaw, did your findings align with real experience?
So the best way I can probably compare this is with the only known value that we had was the twisting movement of the bush due to the parameters of the track, so the geometry of the track. We knew that was going to be about 6.4 degrees. So having put all this information through the matrix, I was able to say that yes, the twisting movement we got was 6.4 degrees, which was exactly what we expected, and the only parameter that was known. So yes.
Okay, thank you. That's just about in time for the next presenter. Thank you very much there, Amanda.
Okay, thank you.
So next up we have Daniel Liddell, and he'll be talking about derailment resistance analysis of an item of on-track plant.
Hi, yeah, that's already introduced. Daniel Liddell presents a derailment resistance of an item of on-track plant. So what I'll talk about today, I'll start with an introduction about the project and a bit about myself, and then go into the methodology of what I did, the results of my findings, and then the conclusion of them findings, and finish with what I learned from the project as a whole. So a bit to kick off about myself. I studied a Master's in Mechanical Engineering at the University of Lincoln, finished that in 2017, and then I started on a graduate scheme at Ricardo Rail. It was a 2-year graduate scheme, with a variety of placements while there, also taking part in the IMechE Railway Challenge, both in 2018 and 2019. And then at completion of the graduate scheme, I joined Ricardo as a consultant, doing the project engineering team, worked on a variety of projects while in that team for just over a year. And then a few weeks ago now, I joined LARAM as a project engineer. So the project I'm going to talk about today, while I was at Ricardo Rail, we got commissioned to conduct a derailment resistance analysis of a piece of plant machinery that was going to be used in the Glasgow Underground. This piece of plant was used to carry 480-foot long pieces of rail around the Glasgow Underground. In doing this and bending and going around the curves, bending the rails created quite a high lateral force, and coupled with the fact there was very low vertical force due to the weight of the machine, there was a high probability of derailment. Thus, the work to actually eliminate or reduce that as much as possible. To do this, the best course of action was deemed application of the derailment resistance standards. These weren't necessarily mandatory due to the fact it was a mainline vehicle, were deemed best course of action to prevent derailment. As you can see on the bottom there, I did a quick analysis early on just to highlight the additional lateral forces that will be created when bending these rails around the track. As you can see there, they are quite high. So the vehicle itself was made up of 7 bogies joined together by walkways. On the bottom left is a schematic of the vehicle. So the yellow blocks show the bogies. They're joined together by red lines, which are the walkways, and at the front they're pulled along by a locomotive. The black lines between all the bogies show the rails as they carried. The top right is a picture from the underside of the bogie. A grab and clamp arrangement is used to hold the rails in place. They were held in the forefoot between the 2 wheels. Due to this, there was no actual wheel sets on the vehicle. They had stub axles, and there was also no primary suspension of the vehicle. There was secondary suspension that was in a seesaw pivot arrangement around the centre of the bogie. So the vehicle could carry up to 4 of these 180-foot long pieces of rail, but it didn't always necessarily carry that amount. It wasn't always fully laden. So we had to test an array of different configurations, because it could carry rails up to 1 to 4 rails or a length as low as 56 foot. These 5 configurations here were deemed to be the most high risk, so these were analysed the most in depth. So the software and standard used for the analysis, due to the machine's very low operating speed and heavily supervised operation, it was considered acceptable to use quasi-static analysis rather than dynamic analysis, which basically is analysing it in a static motion instead of dynamic motion. FEA was used for analysis due to the complexity of the task, and it was deemed too difficult to do through mere hand calculations. As I spoke about earlier, application of the standards was the best course of action. We applied GM RT2141, which is a commonly known mainline standard, which I'm sure most of you will be aware of, and RIS 1530, which is a less well-known RIS just of plant machinery. Like I said earlier, neither legally had to be applied, but it was deemed the best course of action to minimise the risk of derailment. So these standards highlighted 2 main analyses to be conducted. The first one being acceptable resistance to flange fan derailment, which is a wide Q analysis. This was the main one. This was the most interesting one to conduct because this was done on a wheel-by-wheel basis, and this was a ratio of the lateral force on a wheel against the vertical force on the wheel. And like I spoke about earlier, this vehicle experienced very high lateral forces due to the additional force created from bending the rail, and it also had a relatively low vertical force due to the low weight of the vehicle. The limit for this was set at 1.2, and it was prescribed in the standard GM RT2141. The second analysis to be conducted was the measurement of wheel unloaded or on-track twist. So it says delta Q over Q. So this analysis was conducted by raising an individual wheel on a bogie by a set amount and then measuring the wheel unloading of the other wheels on that bogie. It couldn't unload by any more than 60% within the standards, a tolerance of the standard, and this was found in both the RIS 1530 and GMRT 2141. So by applying both these standards and adhering to both these standards, it was minimising risk as much as possible of derailment of the vehicle. So following on, the FEA model that I created can be seen here. Even though there were 7 bogies in total, I only modelled 4 of these due to the symmetrical nature of the vehicle. So I modelled these 4 in depth and then mirrored that on to do the other 3. Like I spoke about earlier, there's no primary suspension of the vehicle, but there was a secondary suspension pivot system that had to be modelled in depth. This brings me on to my next slide. So this is the spring modelling that I conducted for the secondary suspension. As you see here in the centre is the installed position of the spring. So on the bottom graph is the displacement of the spring, and on the left is the force of the spring. Displacement of 0 is the installed position of the spring, which was installed height of 100 millimeters, and you can see the force is 0 at that point. As the spring unloads, there's 9 millimeters of travel to get to its free length, at which point it tops out, and then going the other direction under compression. It has around 25 millimeters of travel till it reaches its solid length, at which point it's coil bound and infinitely stiff. So once I put the data from this into the model, I ran the analysis. For the Y over Q, the results can be seen here. Like I said earlier, the Y over Q analysis was done on a wheel-by-wheel basis, so you'll get many results. But for there's too much to show, so I've just shown the worst results here on the right. As you can see, all are below the 1.2 limit, so this vehicle was deemed to have passed the assessment for the YVQ test. And then this brings me on to the next one. So I did the Delta QVQ test as well. As you can see again, all results are below the 6% limit, so this is deemed to have passed the assessment as well. But what's interesting about these results is that they're all fairly similar. There's not much deviation in the results, and this is due to the seesaw arrangement pivot system that's on each side of the vehicle. This is great at dealing with the on-track twist. As some additional work for the customer, we did some preparation for actual track tests. Obviously, actual track tests are quite expensive and time-consuming, so to try and minimise the amount of work to be conducted, we tried to highlight which load configurations, which arrangement of rails would be the most likely to cause derailment. So to do this, we added a 15mm track twist to the vehicle and then rerun the YVQ analysis. This highlighted 3 instances where it exceeded the limit of 1.2, and these three are highlighted in red on the right. These were highlighted as most adversely loaded conditions, so should be considered for the actual track test. So in conclusion, all configurations were below the respective limits for both the YVQ and the Delta QVQ derailment tests. So the vehicle adhered to the standards set out. So this minimised the risk of derailment as much as possible. Then the most adversely loaded conditions, which should be considered for actual track tests, were provided to the customer as a bit of further work that we conducted. Lastly, what I learned from the project, I extended my knowledge of finite element analysis and derailment analysis. And it was quite early in my graduate scheme, so it was a good opportunity for development in them areas. Further to this, I also increased my knowledge of the standards of derailment analysis and my knowledge of project management. It was a good opportunity for development because I took the project on from proposal stage and got to do it right to the final deliverable, which is a great way to learn at such an early stage of my career. Thank you for listening. Have you got any questions?
Thank you very much, Daniel. Bang on time as well. Go straight into questions.
I've got a quick question, Felix. This is, did you manage to do some practical experiments to show that your analysis was correct, or did you not get down to that?
We never got around to get the results from that, so we highlighted these most adversely loaded conditions to the customer and get that data back, but we never received feedback on that, on how they did in the actual track test, so I can never validate the model through real life results, unfortunately.
Thank you.
So do we have any more questions from the judges panel?
Felix took my question.
Yeah, Steve.
Nothing else to add from me, thank you.
Okay, I'm not seeing any questions in the chat yet. So if
that's good or bad,
we'll give it a moment, see if anyone else can think of anything.
Maybe I'll add something, Daniel. What would you do differently? You were saying you didn't have any real life data to validate, but just from your experience so far, what would you do differently or try to improve?
I think, following on from what you said before, to get in some real life data to input into the model would be quite good. To actually be able to validate with real life with data would be really helpful. If I could do anything again, it would probably be that. To actually validate the model a bit more.
Just a quick one to add to that. What FEA analysis tool did you use?
Strand 7.
Okay. And had you used that in university, or is that something that was completely...
No. It was something I've not used before, and it's not the most user-friendly software I found. Answers and other things like that, they're built around being a lot more user-friendly than Strand 7 was. If you're an expert with it, I felt like you could be really good at it, but as a novice, it was kind of hard to pick up.
Yeah, that was my question in terms of, did you think that actually held you back, the tool itself, or was it the intuitive?
It probably delayed how long it took to deliver the project, because if I'd have used ANSYS, like I say, it's a bit simpler to use, but I don't think it reduced the accuracy of the results or anything like that. I think it just took me a bit longer.
Right, okay, thank you.
Okay, we do have a question for you from Louise Shaw. How did you decide that the tyre standards were valid to use?
Pardon?
How did you decide that the tyre standards were valid to use?
Well, the RIS was specifically for plant machinery, so that was seen as the best course of action as this was a piece of on-plant machinery, and then GMRT 2141, so it's a commonly used standard. It seemed like the most obvious choice kind of thing.
Okay, and there is another one from Gareth Tucker. How do you model the wheel-rail contact in the FEA analysis? Do you consider using a specialist vehicle dynamics package instead of FEA?
We didn't have to model the wheel-rail interface. Usually a static analysis of it, because it was modeled statically, so the wheel-rail interface wasn't needed for it. It was just more the forces created. It was the ratio of the forces on the wheel, so it wasn't the wheel-rail interface wasn't modeled.
Okay. We do have another one from Matthew Hack. Was the rail carrying equipment brand new, or was your work part of its acceptance and a requirement for putting it into operation?
The equipment was brand new, but it wasn't part of the acceptance because it wasn't a mainline piece of equipment. So it wasn't mandated, but it was a new piece of kit, and it was just validating it for the customer more than anything, for their peace of mind.
Okay. Can't see any other questions. Let me just make sure there are. It's quite difficult to navigate these questions, so just to make sure. Oh, we've got another one come through. Andy Roberts, did you find the standards to be applicable, or as a newcomer to the rail, did you think better or alternative limits would be appropriate?
They weren't the easiest to understand, the standards. They weren't very clearly displayed with the information I needed. Obviously, never even used them before, but I got a lot of support at work to help me through actually trying to understand them. But there was a bit grey on some areas that could be cleared up a bit better. I can't remember the specifics of it in a minute.
Okay. One more, last one. Thanks everyone for the questions, by the way. James, how did you measure the Y forces for the Y over Q analysis?
The Y forces were measured at the force created from bending the rail. So it was the lateral force. Obviously, the force created with bending the rails around the curves of the track was created the lateral force in the rail where the wheels would have been. So let's translate on that. That makes sense.
Okay. Unfortunately, that's all we've got time for questions on that one, because we're going to have to move on to the next presentation. Next presentation. Thank you very much, Daniel.
Cheers. Thank you. Bye.
So next is Gabriel Giorgi, and I'll let him introduce his presentation.
Yep. So good evening, everyone. My name is Gabriel Giorgi, and I work as an innovation engineer for Costain Limited. I'll be presenting on the IRAM prototype today, and before I start, I'd like to thank everyone on this call for dialing in. I hope you enjoy this event and find my presentation on the future of rail insightful. So quickly, for this presentation, I will briefly run through an introduction to IRAM. I will discuss more and go into more detail on what the IRAM platform is, after which I will talk about further applications and exploitation activities of the prototype before bringing the presentation to an end for any questions you might have. When I think about the future of rail, I envision a digital twin for all railway infrastructure, a future where we no longer have delayed trains, service disruptions, passenger complaints, overcrowding at stations, and so on. Industry experts and studies have shown that the causes of these delays is mostly due to unexpected asset or rail equipment failures, so such as your signals on your track side or even escalators at your stations. So what I'm trying to say is I see a future where passengers can experience safe and connected travel. My contribution to this vision is IRAM, which I believe can transform how equipment and our assets are monitored and maintained. So rather than a find and fix approach to asset failures, which the industry is used to, IRAM enables a predict and prevent working system. So now we can predict when any equipment might fail, take preventative measures before it actually happens. This new system or culture will form part of the digital twin for the whole of Britain and improve our rail infrastructure. So what's a digital twin? My simplified version or definition of a digital twin is that it is a computer or virtual replica of a real-life physical asset. So for my executive summary, from the vision I had for the future of rail, I worked closely with an SME partner called Enable My Team and a university partner called the University of the West of England. We secured £1.6 million worth of funding from Innovate UK in 2018 to develop a prototype for the rail industry. The prototype we developed was called IRAMP. IRAMP stands for IoT-enabled platform for rail assets monitoring and predictive maintenance. We aligned the development of IRAMP to 6 key rail operation challenges provided by Network Rail. So Network Rail own and operate the railway infrastructure in Britain. So throughout the development of IRAMP, we made sure we had constant engagements through workshops and various consultation events with Network Rail. The IRAMP prototype is currently at ITRL level of 6, so it is a working prototype, and various stakeholders have been interacted with to ensure we provide real-time maintenance, monitoring, and visualization of assets for these stakeholders. Other key positives of IRAMP include the social value benefits that have come about, such as the upscaling of the SME and the university partners who can now win more work with clients and develop their own capabilities. So what really is IRAMP? Well, the easiest way to define it is that it is a data analytics platform with 3 main processing and visualization modules. You have a simulation platform, an AR module, a virtual reality module, all developed to support the diverse railway work that's being carried out in the UK. So we start with the interactive and holistic simulation platform. When I look at what the slide shows is that we have a web-based system that is flexible enough to integrate with other clients' softwares and supplier platforms using APIs, which stand for Application Programming Interfaces, and these APIs allow these systems to talk together. This diagram illustrates the end-to-end data processing pipeline that's found at the back end of the IRAMP software. A wide range of data inputs such as your drone surveys, your videos, your LiDAR scans, and so on can be analyzed and processed through the IRAMP in a secure AI-driven data analytics platform. After this data is processed, it is transformed into useful and actionable information that can be produced in real time and displayed as required by your end user. So if you need reports, CSV files, PDFs, or even immersive platforms, which I'll talk about in my next few slides, you get data coming in from your IoT sensors and your equipment, and on the other side, you get real-time information that would enable you carry out your work as a field engineer better. Next slide. On this slide, you can see what the front end looks like. So I've captured a few screenshots to sort of help you visualize what I'm talking about. Firstly, you can map out the whole rail network onto the system. So assets along a railway network or route can be visualized and monitored remotely. Any faults, errors can be flagged up automatically through the AI-enabled IRAMP system. Obviously, when you think about the UK, we've got over 2,500 stations. Network Rail has over 20,000 miles of track to manage and monitor as well. So having a system where you can bring all of this data together poses a lot of benefits, such as a reduction in the amount of rail engineers having to access tracks. And apart from that, also making maintenance safer and less service disruptions to the system. The next visualization module I'll be talking about is the augmented reality one. The information we produce from that simulation platform that I've just spoken about is then transferred, or shall I say, is overlaid with digital elements and computer-generated images and objects, such as 3D models, live or historic asset information, providing a more immersive alternative for stakeholders to work with. What you then have is you're bringing all these various data sources together to form a mini digital twin. This slide is a quick demo and it illustrates how we all work together for the augmented reality module. On the left-hand side, you have your IoT sensors in red, and behind it, you've got an AR marker or an AR code. So using a camera on your phone, on iPad, any smart device, what you can do is you scan that code. And for this example, we have a railway station where the IRAMP platform has flagged up a few alerts that can be accessed by any relevant rail persons in real time. For example, your station manager, or your railway staff, or remotely and from anywhere. They can interact with this 3D model, communicate, and respond as necessary without having to travel around. The next slides further show some of the screenshots which I've captured from the platform, again just highlighting the flexibility of IRAMP and how we can work with various systems, whether it's Network Rail's systems such as the Orbis system, or even live sensor data from other assets. The final module I'll be talking about is the visualization module. The VR module would allow for the simulation of 3D railway environments and assets in a virtual reality space. Again, you're going to link the simulation with information from the IRAMP interface and holistic platform, giving you richer content to work with as an engineer. It is worth noting that the VR module has various applications across an asset's life cycle, and not just during the maintenance phase of the asset life. The IRAMP virtual reality module will provide an immersive platform for real-life virtual rehearsals of real-world rail challenges or scenarios. So these scenarios can range from pedestrians in a station, so passenger flow monitoring and management at railway stations to prevent overcrowding and support safe passenger movement, to other scenarios such as planning, maintenance activities as well. So even digital training. So before you go into a station to do any work, you put on your VR headset and you can plan your works ahead to cause the less discomfort to the rail users, for example. Pretty much the VR module can help rail operators provide better services and improve the customer experience across the station. In terms of further applications and what we've been working on, so further to the development of IRAMP, we have started testing and trials on real-world events, or real-world scenarios. So here we have merged robotics and IRAMP together to enable a completely autonomous inspection of a rail system. LiDAR and video data taken from the robot scans were captured and presented through IRAMP. On other projects that Costain's working on, such as complex delivery programs, where access to some sites or areas is either difficult due to rough terrain or hazardous materials, in that space, we have used virtual reality to simulate some of those works. We're also currently producing a railway station digital twin, working with one of the key rail stations in the UK. In summary, to conclude, studies such as the Gemini Principles by the Centre for Digital Build Britain have shown that the rail industry's challenge is not with technology. The technology actually works. The problem is the data integration. These various technologies have various systems that they work in. So how can you bring this all together to provide useful information for the rail industry? That's where IRAMP comes in. The IRAMP prototype will provide a holistic platform for processing and visualizing this data, providing actionable information for clients such as Network Rail, and will bring the digital transformation needed to the rail industry. Thank you very much for listening. My name is Gabriel Drojai, and you can get in contact if you want to discuss further. Thank you.
Thank you very much, Gabriel. There, another interesting talk on digitalisation and some interesting aspects on the application in the rail industry. So let's go to the judges for some questions.
Yeah, question from myself, Gabriel. I suppose, obviously, another fascinating presentation, so thank you. But the question for myself is, what was your direct input into this? Did you lead the team that created it? Were you responsible for a specific part of it? Could you just run us through what your involvement was, please?
You've got to come off mute.
You're on mute, Gabriel.
Sorry. My background is in mechanical engineering, and on joining Costain, worked on site for a few months before joining the innovation team. So actually, I was tossed into the deep end of the river because I started off project managing this project. So acting as the project manager as well as the M&E interface for where we were looking at assets we wanted to visualize. So working on a site where we've got rail systems, I go on there, highlight an asset we want to work on or do a trial on. I get all of the designs, all of the data, make sure it's aligned to the requirements, industry standards, provide those data sets to the SME and the university partners, then we work collaboratively to deliver the project. So apart from doing the engineering works behind the scenes, I was also managing sort of the delivery of the whole project.
Lovely, thank you.
Quick question from me. You were talking about practical application.
Yeah.
Has there been any application of the prototype which you can talk about? And
yes.
What were the outcomes?
Okay, so first off, it was a 2-year project which started off in 2018 and currently finished in April of 2020. So when I say TERL level 6 and a prototype being developed, it's a prototype. It means that a prototype has been developed in a specific environment related to the rail industry rather than on a live rail site. In terms of what's been trialed, we've gotten data sets, real life data sets from Network Rail, and actually trial these data sets in a lab environment and in various related environments. But in terms of a live route, we haven't done that. So the slides I had where you had the sensors leading onto a station, those are some of the real life trials we've actually done, and we've actually seen sensors placed in your stations actually transfer information to the IRAM platform, and it actually works. So although we've not trialed it on a real route yet due to the various risks associated, again, buying from clients who are willing to shut down a route for you to test it, it has been tested in the laboratory and the relevant real environment as well.
Hi, Gabriel. It's cool to be here. So really good presentation, actually. Really liked it. It is a look into the future. So what you're saying is a lot of this is in proof of concept stage. Is that correct?
Depends on how you want to look at it. I mean, if you can get a client to happily open their routes for me to trial it, more than happy to show it's past proof of concept. But yes, I can also agree it is a prototype that hasn't been tested on a live route yet.
No problem. That's fine. That's where all these things start. So tell me, that's a lot of data you're going to suck up from the railway.
Yeah.
And tell me a bit about the data security elements of this, because we're quite precious about the security of our data for obvious reasons. And how would you overcome that?
So from the initial stages, we made sure to keep the client engagement on. So, and that's one of my slides, the sort of set achievements was over 10 workshops with Network Rail, who is a major client in the UK, as well as all other industry experts. So the key thing is from the start, we've collaborated with the key stakeholders involved with managing the railway system in the UK. In terms of standards, we've aligned to the ISO 5500, which is for asset management, as well as that for information management. The DSI produced one that is ISO 27001. So the way we've built the system architecture is in a safe, sort of secure environment. Because then as a business, we're very well known across the UK as a tier 1 contractor. We use some of the Microsoft Azure platforms as well as AWS to provide open source integration method for various clients. So it's a very sort of secure network that's been developed, and definitely nothing for people to worry about. But again, we understand we need to keep developing it, and it's a very flexible platform.
So it will be in the cloud?
It will be in the cloud, yes.
Right, okay. So, so access will be limited to those people who would pay for the platform, but in terms of its security protocols, you think it's designed in a way that will make it inaccessible to everyone else?
Yes, because we'll ensure through the APIs we're providing this, again, aligned to those standards that have been set by the industry.
Sure. And one final bit is, so it was very physical system related, I noticed. And a lot of the challenges that we have as railway operators are for moving assets, for example. And so reliability, performance is an emergent property of multiple physical assets, as it were. What's your thoughts on that within this system? Have you considered that? How does that get uploaded? And like we discussed earlier, to build a statistical viable baseline, it could take up to 2 or 3 years. Where do you think you are on that journey?
Yeah, very good question. So I think to start with IRAM platform, it's capable of monitoring assets, whether it's static or moving assets. So one of the proof of concepts, which I did not show, obviously, because I wasn't able to upload a video in terms of my time limits, was the use case around overhead lines. So that is sort of an asset that's linear, and you've got your cameras on trains, so CCTV or video feeds that this IRAM platform can capture and can work in terms of the automated asset recognition system we've put in place to solve that problem. So in terms of moving assets or linear assets that go on for a long space, that is something we have thought about, and we have used data sets from the Network Rail yellow trains, for example, to bring that proof of concept to life. In terms of where we are for the future landscape, again, I'm always open to sort of improving on it. It's at tier level 6, and we're looking and hoping that we'll continue getting client engagement, and we can continue to transform this to something that can be used on our live rail systems and transform the industry.
Thank you.
Thank you very much, Gabriel. There was quite a few questions coming in there, but unfortunately we've run out of time for questions. So thanks again for your questions from the audience, but it's time for a break now. So what we're going to do is we're going to have 10 minutes and we'll come back. Well, it might be slightly less than 10 minutes, but we'll come back and we're going to get straight on with the next presentation at 18:45. Thank you. Okay, here we are again. Emma, if you could load the next presentation, please. And I will pass you all on to Amy McDonald.
Hi everyone. So tonight I'm going to talk about the second railway challenge that I encountered in 2019. The first railway challenge was the IMechE railway challenge, which I was the S&C Lavelin's team leader for that, in which I gave a presentation to the Scottish division of the IMechE Railway Division in January of this year. So the second one is the Mark V coach introduction for Caledonian Sleeper. First of all, I'll just give a bit of an introduction to myself. So I'm a graduate engineer from S&C Lavelin, based out of the Glasgow office in Scotland. I graduated from Strathclyde University almost 2 years to the day with a degree in electrical and mechanical engineering. And I've spent the last 15 months working with Caledonian Sleeper. I joined the project last April, initially for 12 weeks, with expectation to finish in June last year, and here I am a year later. So what have I done in the last 15 months? When I started thinking about it, I started to list all the assignments that I'd done, and the list grew and it grew until I got to this. So from the World Cloud, there's an awful lot of things there. So it's been quite an exciting 15 months and been very, very varied. So I spent a lot of time on the trains. I've also spent some time doing document reviewing, looking at modifications for the fleet, and it's been a good experience and a really good first project to be involved in within the rail industry. So moving on, who have I worked with? So that list then got down to 3 different companies. So again, quite a number of people on that list. And part of that is due to Caledonian Sleeper's supply chain. And so people like GBRF with their locos, and then with outstations in Scotland, and then Alstom, and of course the manufacturers, CAF. So this evening I'm going to talk about a few of the different assignments I was involved in. The first is the ASDO database development. So for those of you that don't know what ASDO stands for, it's Automatic Selective Door Operation. I was predominantly in charge of the Highlander portion of this database, as the Lowlander was finished before I joined the project. So with Highlander, you've got the how do you put it, the variants and platforms down in England. They're all quite long, they're all quite similar, whereas in Scotland, very, very varied, especially up the West Highland line. So initially we were looking at the physical characteristics. Where are we going to put the car stop marker boards? How are we going to get the optimal position for the coaches to be on the platform? And bearing in mind, within Scotland, you've got 3 different portions, maybe 3 different formations, 3 different local formations, and different running orders as well. So that initially was a bit of a challenge. So once we got down to knowing where the coaches were going to stop on the platform, what platforms were going to be used, put this into the database software. So as you can see here, a lot of the stations are divided into northbound and southbound. So this just divides it into which direction they're travelling in, meaning that you can have 2 different door patterns within the system rather than just the one, which you definitely need for the Highlander routes. And then you also need information like the GPS coordinates of the station, the geofence, which is the bubble around the station. So when the train comes into the bubble, the door pattern is released, and then the train manager knows what the door pattern is going to be, and he knows where to stand to enable the doors to allow the passengers off. Then you have the additional points at the reset points. So within the station, between the stations and the route, you have reset points, which allows the system to know exactly where it is. So if you take Edinburgh to Glasgow, for example, there's multiple routes that you could take. So within the reset points, this helps guide the system to know exactly where it is. And then between the different reset points and stations, these are all joined up by segments. So within the segments, you add in the track length, and that's where the odometer takes the readings from that compares what it should be to what it travelled, and then that also adds to knowing where the system is. So on the left-hand side of your screen, this is the pictorial view of the database. So from here, you can see the stations such as Bridge of Orchy, Rannoch, Career, and then you've got the reset points and the segments in between them. And you can also see it's divided into northbound and southbound, allowing for 2 different door patterns. And on the right-hand side of your screen, you can see what on-train it looks like. So the train manager, this is his view. He can see the formation, he can see how many coaches are in it, you can see what locals on it, and then he can see the door pattern that will be released at the station. So in this instance, you've got 5 coaches and all 5 coaches will be enabled. If it wasn't going to be all 5, it was going to be 2 or 3, that would show up in a different colour. You can't quite see the key, but it does show up in a different colour, which all aids and just the train manager being able to visually see what's happening, and then so he or she can get prepared and to know what to do. So the second assignment that I'm going to talk about is the fault-free runs. So within the new fleet of Mark V coaches, there's 75 vehicles across 4 different types. All the fault-free runs are now completed. This was started last April and was completed in March of this year, so it did take a wee while to do. All the runs were done either to London, Lancaster or Carlisle. And then throughout all these runs, we did different activities. So the first one was system functionality test. So this was looking at the TCMS, making sure that all the alarms that were coming up were expected and there was no ones that we weren't expecting. And then looking at ASDO, PIS, making sure they were functioning right. And then also looking at the emergency system. So emergency windows or the pass comms and making sure that they worked as we were expecting them to. We also looked at the window noise. So there was issues to do with the seals around the windows. So all the 75 coaches went through a modification program. And then we were checking to look at if the noise from the windows was going to be detrimental to anyone trying to sleep, which I'm sure some of you have travelled and you'll know if this is true or not. Within the berths itself, we also looked at the en-suites, making sure they were all functioning. Was the water hot? Was the pressure right? Were the plugs working? Were the lights working? And then finally, we also looked at the software. So obviously 11 months is a long time. So we needed to make sure that all the software, when these trains were going through their fault-free runs and their QPAT process, were all being made to the same software, so there wasn't going to be any compatibility issues when they were rotated into service. From the pictures on the screen, you can see these fault-free runs were not always fault-free. So on the left-hand side, you can see the pass call, which shouldn't be in my hand, it should be fixed in place. But I can assure you that that went through a whole fleet review and they're all working as they should be now. And then on the right-hand side, you can see that the bottom label isn't quite the right way around. So moving on, one of the big sections I did last year was the trial operations. So I spent a significant, and I mean significant amount of my time either travelling to or at Aberdeen, Inverness and Fort William. So the outstations for the Highlander route, this is where all the suppliers look after the train during the day. So either LNER, ScotRail or GB and ScotRail and Fort William. So everyone involved needed to make sure that the shunters, the fitters, the cleaners had their coach familiarisation, they knew what to expect. They also needed to look at CTing and tanking. Obviously, with the new Mark V fleet, you've got a lot more tanks, both freshwater and CT. So they needed to know how long it would take to fill them or empty them, depending on what it is. And yeah, this took a long time. Comparing the Mark IIs and Mark IIIs to Mark V is obviously a big jump. And I think I couldn't tell you how many questions I answered from the fitters and the cleaners about how the trains work and what to expect. But, so it was a learning curve for me as well as for them. Another part of the trial operations was the Waverley shunt. So for the Highlander operation, it comes southbound from the outstations in 3 portions and then joins up in Waverley and travels south of the 16 coach rake and then does the reverse coming northbound from London. So joining 3 coaches, 3 formations together to form 1 rake sounds really easy. And when we were doing this on paper, moving paper trains and paper shunters about, I was like, yep, we can do this easy. In practice, not so much. There's a lot of moves and there's a lot of positioning that needed to be thought through. Just move that coach like a wee bit further forward or a wee bit further back. So that was a bit of a learning curve, and it took 2 different attempts to get it quite right. And I'm sure they'll be learning throughout the rest of the Mark V lives. This picture here as well is very lovely. The Mark V coaches are sitting in the sidings at Cranlarrick. station, and they shouldn't be there. So there's problems we encountered throughout all of this. So quickly moving on to the lessons learned. The one for me, the top one, and I think this applies to the rail industry in itself, is plan A's are important, but so are plans B's, C's, all the way down to Z's. Testing of fully integrated systems is key. Again, with all these new technologies, that is a massive part of the new fleet introduction. Within this project itself, communications between stakeholders is vital. There's a lot of people involved, and that was a big challenge. And finally, I'll just move on to my very last point because I'm being told to quickly wrap up. That delay repay does not exist for trial operations. I was delayed a lot, and if I had got delay repay, I would have earned an awful lot of money, so I was quite sad about that. But thank you for listening, and if you have any questions, please.
Excellent. Thank you very much, Amy. Very interesting presentation there. Straight into judges' questions.
Sophie, a question from me. Do you consider this to be a successful introduction, or would you do something different if you were in charge of this whole thing next time?
I think it's successful because there's all 75 vehicles in and can be in service now. So for that point, it is successful. I think in terms of actually introducing them, there was an awful lot of issues with itself, with the locals, with the coaches, with training. There was a lot of delays, and I think that could have been slicker. So yes, it was successful, but the process, maybe not.
Hi, Amy. Great presentation. So we're here at the IMechE presenting, lots of people in the audience. Actually, you were trying to solve a challenge there, which obviously is pertinent across many parts of the railway, actually, from metros to Network Rail as well. Did you reach out to colleagues or other companies or potentially other areas which potentially have had this challenge and solved it or not, for their experience?
I think within the SNC Lavalin as a company, one of the things that I think we do very well is help with new fleet introductions, and there's an awful lot of experience there. So both within the company, both within the people that were involved in this project itself. I think that really helped. Like, they knew the pitfalls already, and they knew what not to do and what to do. Obviously, this in itself, there's no new sleeper coaches being introduced since probably the 70s. So that was going to be a completely new experience where not many people had any inclination about it. So I think there was no one really to ask on that side of it, but actually introducing stock, that was easy to go and find, and definitely did that,
Okay. Thank you.
That sort of leads on to my question a bit, actually. With regards to the experience that you and your colleagues have got with rolling stock introduction, what would you say was the biggest surprise that you all found collectively? Because, as you rightly say, a sleeper introduction is a very different beast to, for example, LNER's experience with the IEP. So what would you say was the biggest surprise when you were introducing this fleet?
I think that's actually quite a difficult question because there's quite a lot of surprises. I think one of the big things is it sounds great to have en-suites on board, and it sounds like a really good selling point, but in practice, that's a difficult thing, purely from stuff like in outstations and Highlands, is there enough water pressure to get the tanks filled, and sort of things like that at the design stage hadn't been thought of. And I think that's maybe something that in hindsight they would have done, is looking at when they were designing the coaches, looking at the ramifications of that.
Oh, that's great, thank you.
Okay, if that's the judges done, we've got a question.
Sorry. Go on.
We've got a question from Mike Molyneux. When do you think the train will be as reliable as the train it replaced?
No, absolutely not.
So there is no when.
No, I don't think it's going to last as long as the Mark IIs and Mark IIIs did.
Okay. Felix, did you have one?
Yes, I was going to ask about the software. To what extent the software was a problem, because the original channel tunnel X's for sleepers were a disaster from the software side and the computer side.
Yeah, definitely. If you look at the Mark IIs and Mark IIIs and look at the Mark Vs, they're just not comparable in terms of what the technology is on it. And I think it's a massive learning curve for the people involved in it, because previous to my presentation, all these presentations are talking about data, and it's the same with these. There's so much data on there, and it's what do you do with it. And I think that'll be a learning curve for Casual and Sleeper, making sure that they're harnessing that and using it to their advantage. In terms of like maintenance and stuff like that, making sure that all the coaches are kept up to the same sort of software standards is a challenge in itself. They don't go through the same depots every night, and the maintenance cycle as well, proves a bit to be an issue as well in terms of that.
Thank you. Very good presentation, by the way.
Thank you.
Just in time. Thank you. Yeah, very good presentation, Amy. Thank you very much. We're moving on to the next one now, and we welcome Thomas Ollison.
Thank you for that. Good evening, everybody. My name is Thomas Ollison. I'm an early design engineer at Atkins, and this evening I'm going to be talking to you about the pantograph monitoring project that I was working on. So during this presentation, I'm going to give you an overview of the work completed by Atkins over a 9-month period to install the Pantobot camera system at Southcote Junction. What I'm going to do is I'm going to start by giving some background to the project and a bit of context as to what this system actually is, and then go on to discuss my role and what I was responsible for. I'm going to follow this by explaining the system requirements and how this influenced the structure selection process. I'm then going to present our final design of the core components, Pantobot, and the additional design elements, MVID and weather station. And then finally, I'm going to summarise with this project and reflect with some of my own thoughts and conclusions. It's going to last for about 10 minutes, and I'm sure there'll be some questions from our panel and attendees afterwards. So to start us off, what is Pantobot? Well, Pantobot is a camera and lighting system developed by Camlin Rail, which photographs passing pantographs and uses machine vision to construct a 3D model. So the image on the slide here shows an installation from Italy. And what you have is a freestanding mast with 2 lights and a camera at the top. And the way it works is as the train passes, a motion detector is triggered, the lights flash and briefly illuminate the area, and the camera takes multiple images of the passing pantograph. This data then gets fed down into the processing enclosure, which uses machine vision to construct a 3D model of the pantograph. Now, the motivation behind installing the system is asset monitoring and protection. A damaged pantograph on the network can cause excessive damage to the OLE. And the idea with this system is that if a pantograph is damaged, the signaller can be notified via Pantobot and can then pull that train out of service before it causes any more damage. So the camera, the lights, and the processing enclosure, that's all been designed by Camlin. And what Atkins were contracted to do was design the infrastructure to support this system. So my role in this project was as the Assistant Contract Engineers Manager, or CEM. And using the project, the CEM is responsible for the overall technical submission. So I started off as being responsible for managing a lot of the administration of this project. This was things like document control and sending technical queries to Network Rail. And as the product developed, I became involved in CAD support and design. So I was the early designer and was responsible for producing all of the 2D drawings and 3D models associated with my discipline. And I was also there supporting Camlin with their CAD problems and trying to get their files in the correct format so I can incorporate them into my model. And finally, and probably most importantly, I was there to ensure cohesion amongst all of the discipline's designers. I had to make sure they were all working together and then integrate all of their design aspects into the final submission. So the image on the slide here is the general arrangement which I produced, and you can see it's got some civil elements, some OLE elements, it's got a lot of Camlin's equipment in there as well. So I had to understand how everything would work and how it would all fit together at the end. So moving on to the design process, we first had to try and match the system requirements from Camlin and the product requirements from Network Rail. And from Camlin, there were 3 main points. The first was the relative position of the camera lens to the contact wire. So due to the focal length of the camera, we had to make sure the pantograph was a certain distance away from it, and we used the contact wire as a datum point. By achieving this distance, we ensured that A, the image would be in focus, and B, the entire pantograph would be captured. Second, they had to think about the number of contact wires in the field of view of the camera. If there were multiple wires over the top of the pantograph, then less of it would be captured in the image, and you get data loss and the potential to miss a defect. And third and finally, they had to think about the track geometry. So if you installed this camera system on a curved piece of railway, because of variable body roll from the train, the pantograph could be in different positions. And similar to the wire run problem, you could then have loss of data because ends of the pantograph might get cut off the picture. From Network Rail's point of view, they wanted this system to monitor all of the pantographs on the western route and monitor all of the junctions, all the traffic through junctions, so it was all photographed. And the initial problem here was trying to find a site that met all of these requirements. After some deliberation, we decided that Southcote Junction would be the first of 6 sites where the equipment would be installed. And the initial plan was to design a new freestanding structure to support the equipment, similar to the installation I showed you from Italy. We very quickly realized, though, that we could utilize an existing OLE structure, and it had some significant advantages. For example, there'd be no need for a buried services survey or a foundation design. An overall design would be cheaper and have a shorter installation time because the steelwork physically already existed on the network. There were some drawbacks to this, though. Camlin had never installed it on an OLE structure before. They'd only ever used a freestanding mast. And attaching it to an OLE structure presents some additional challenges, such as signal sighting and electrical clearances. We decided, though, that the pros outweighed the cons and decided to use the Series 1 monoboom at Southcote Junction. And the reason we chose this structure is because our analysis showed that the boom is only at 15% low capacity, and therefore we were confident that it could support the Panspot system's weight. So the next step was for me to complete a desktop study to review the available monobooms in the Southcote Junction area. I started by looking at the layout plans to find structures in suitable locations, considering all of Camlin's requirements, but now also thinking about if there was a suitable power location nearby we could use. Once I had a list of these structures, I then found the relevant OLE cross-sections to see if there was any additional equipment installed on them that would have impacted our design. At the end of this process, the structure I selected was BKE 60588. Now, the problem with this desktop study is it was all done using AFC, or a proof of construction data. The cross-section and the layout plans therefore may not have been an accurate depiction of what had actually been installed on site. Therefore, a site visit was necessary to confirm the accuracy of the desktop study and also look at other factors such as access and any unexpected equipment. And a good example of that last point is shown on the slide here. So this is a site photo we took at the structure, and the thing which is circled on the left-hand side is a solar panel which is connected to a track lubricator. And it doesn't impact our design at all. It's about 20 yards away from the structure and it's all installed at ground level. But we didn't know it was going to be there until we got to site. And there could have very easily been something else installed on that structure we weren't aware of that would have impacted our design significantly. Once we were satisfied that this structure met all of our requirements, we moved into the core design. The first thing was our survey team went out and took a point cloud survey of the structure so that I could build an accurate 3D model of it. And what I needed to know really was the registration arms and how they were attached to the structure, where the contact wire was, and where the track was. And once I had all this information, I could put the camera in the correct position, horizontally relative to the track, and vertically relative to the contact wire. Once this was done, the model got passed over to our civils team, who designed an OMF, or overhead mounting frame beam, that would hold the cameras in this desired position. We then specified a cable management system along the boom and down the mast, and our electrical team specified a power distribution enclosure, which is our connection from the line-side power source to the Panspot system. And then finally, our civils team designed a small bracket for holding this power distribution enclosure, as well as the processing enclosures, which are all held at about chest height. So I briefly mentioned earlier there were some additional design elements introduced later in the project, and these were MVID and weather station. So MVID, and that's the CAD model shown on the left, is another small camera which is used for photographing the vehicle body. And what this does is it gives you the unit number so you can actually link the pantograph to the train it's associated with. The other component, the weather station, is a standalone bought-in thing, and what this does, it measures things like wind speed and rainfall, and the idea of this system is to try and correlate weather conditions to pantograph damage. Now luckily this wasn't too much of a change to our original design. There was one extra cable to connect the weather station to the processing enclosure, and we had to design 2 new small brackets to hold the MVID. So this is the combined 3D CAD model of our final proof of construction design. So what you've got is a camera and 2 lights supported by the OMF beam over each track. We've got a cable management system along the boom, which is C-section channels and cable cleats, and a cable management system down the mast, which is tray work and cable ties. At the bottom of the mast, you've got 2 processing enclosures because you need one for each camera system, and the power distribution enclosure in the middle. You've got an MVID on the inside face of both masts, and the weather station's installed at the top. So, in conclusion, this was my first project at Atkins. It started around about the same time that I joined, and for me, right off the bat, to be involved in a project of all these different disciplines was fantastic. I was working with the OLE team, the civils team, our electrical team, the PUA team. I was dealing with external suppliers like Camlin and with Network Rail, who are our main client for a lot of the work that we do. Like I've said, this is a novel system, and it's the first time that Network Rail have actually tried to install it on their land. So for me as a new graduate in the industry to be involved in such an innovative bit of technology, it's an absolutely fantastic opportunity for me. Talking about our design, it's universal and you can replicate it on more sites on the Western route. So with slight modifications to account for different registration arm positions and different contact wire heights, you can basically copy and paste this onto any monoboom structure. Once we were happy with our design, a prototype was made and trial installation was completed at Cockerby Training Centre. So the image there shows them craning the OMF beam into place. And then we submitted our final design to the client as a proof of construction on the 4th of March 2020. So thank you all for listening to our presentation this evening, and I'll be more than happy to take any questions.
I've got a question for you, Tom. Please tell me if it's an unfair question. I suppose one of the things that comes to mind is that you're talking about the weather station installed.
Yeah.
What considerations were put towards the fact that you know, a railway's fundamental design is to move things around? Whether elsewhere could skew those results? Does that make sense? So, for example, if it's raining in Wales and you're running a pantograph from Wales, but it's dry at your detection site, has that been thought about?
Yeah, so one of the main focuses of Panzerbot is this asset monitoring. So it's about repeat defects, and this is where having those multiple sites comes into play. So this is the first site at Southcote Junction. There was planned to be one near Morton, Bristol Parkway, Seven Tunnel Junction, and then all the way up to Paddington. So if you have all the pantographs coming through Paddington, and they're absolutely fine, and then 90% of those pantographs are coming through Southcote Junction with a chipped contact strip, you might think, okay, well, I don't really know what's going on here. We're having a lot of defects in that area. You could maybe look at the weather data and see, well, actually, it's normally got quite high wind speeds around here. Maybe that's pulling the contact wire across it in a way we're not expecting. I agree that the weather station, I personally feel like it didn't add too much, but I can see the logic behind wanting to install it on the structure.
Yes, I suppose it's about looking at the various detection sites as a whole.
So this is one in isolation. This is like the trial site. Once you have those multiple sites on the Western route, you'll get a better picture of what's going on across the whole network there. And the weather station as well is such a small, lightweight bit of equipment. You could put that on more structures in between without the whole Panzerbot system. It's quite detached from it.
Perfect. Thank you, Tom.
No worries.
Felix, it's a very good presentation, and what I'm interested in is how much does it actually cost to put one of these up, and what's the distance between them which actually makes sense? Because if you have got too few of them, then a fault can develop between them. If you have got too many, then the cost just goes through the roof.
Okay, so in terms of the actual cost of the equipment, I don't know. In terms of the installation, so when they did that trial setup at Cockerby, it took them, I think it was about 6 to 8 hours to crane it in. So there's always a cost associated with installation. You've got to get the possession and all that sort of stuff, and like plant hire. But by using the early structure is how we try to reduce the cost as much as possible. And in terms of the number of data points you've got along that route, so the initial plan currently is to have 6. And I agree, they are quite spread out. So I think that they're trying to trial the whole thing. So if you have those 6 data points and they realize they're getting good data, but not quite enough, they might go back and try and install more at more frequent points. And like I've said, because our design is universal, it's not that hard just to get the drawings out again, make the slight modifications, and then put them where you want. Because overall, I believe it is quite a cheap system. The expensive bit is basically the camera. That's the bit which has the most cost.
Okay, hi Tom, Goldie here. Great presentation. Just trying to think a bit differently. I mean, I'm always reluctant to have more stuff put within the sort of bounds of the critical part of the railway. And here we are, we need a 6 to 8 hours possession, craning it in, etc., etc. And like Felix said, you might need a few of these, and they'll need to be maintained and looked after and all those sorts of things. How much effort went into actually saying, can we find a solution where we actually don't have to take a possession of the railway?
So it comes down to this. We basically factored in the fact that even if you wanted to do it as a freestanding post, you'd still need a possession to do it, and there's no other way to install the equipment. In terms of the cost, the way to look at it is that if this system stops one rip down of the early contact wire, it's paid for itself 5 times. Mm-hmm. And that's the thing, if you have a contact wire come down because of a broken pantograph, you shut the whole network, you have to go in and rebuild all the wires. So as soon as it prevents one rip down, which I'm sure it will, it's paid for itself several times over. And in terms of putting the critical path, do you mean from like a safety aspect as well? Because there's now something else hanging over the railway?
Well, there's not only something else hanging there, there's always demands on possessions for the specific, that component of the railway.
Yeah.
It is a big possession, it's not a small possession.
Yeah.
And, there's other functions, there's other people who are all looking to add equipment in that.
Yeah. So you have that initial hit from the installation, and admittedly that's quite a long period to have a possession. But once the equipment's in, its maintenance regime is about once every 2 years. And that basically involves dusting off the lens.
Sure.
We've made sure as well that it's clear of the OLE as well. So in some cases, depending on which structure you put it on, you might not even need a full isolation to actually maintain it as well. So we've had that in mind because we do appreciate the fact that if you had to go up and look at it every 6 months, it wouldn't be cost effective. But because that maintenance regime is so sparse, it actually does work out cost effective. Once you've taken that initial hit of installing it, which is kind of the same for OLE in general, it's quite a big financial hit up front.
We're going to have to, sorry, to sort of rush you along now.
Yeah, okay, sorry about that. I digress, but thank you for your question.
Okay, thank you.
Apologies for those who have sent questions in. We just run out of time to ask those questions. So we're going to have to get on with the final presentation from Fahad Raga.
Good evening, everyone. My name is Fahad, and I'm currently a graduate mechanical engineer at Transport for London. In this presentation, I want to talk about a project I worked on during my first placement in the track maintenance team around squat and squat type defects. So to give you an outline of this presentation, firstly, I want to give you a bit of a background of the project and its aims. I then want to delve a bit into the history of squat defects and touch upon some defect characteristics with particular reference to the initiation and propagation mechanisms. And finally, I want to talk about squats in the context of London Underground. So squat defects are one of the most prevalent defects found on our network, accounting for around 37% of all defects found on track in 2019. Having said this, the nature of squat defects, with particular reference to the initiation and propagation mechanisms, are still not well understood. This is highlighted by the fact that our TfL standards, our inspection standards, are adopted directly from Network Rail. You may be thinking that this isn't too much of an issue. However, recent research has shown that the type of defect found on our network may in fact differ from that found on the Network Rail infrastructure. And this is where I came in. My task was to look at the literature, past and present, to firstly determine the type of the nature of the squat defect on our network. From here, I would look at the TfL inspection standards to determine the reasons behind our current squat defect limits, and then to conclude whether or not these are appropriate for the type of squat defect found on our network. To do this, we first need to look at this as a snippet from the and this table describes action that an inspector will take when they find a squat defect on track. The two key values to pay attention to here are the squat defect length and the depth. So to give you an example, if the length of the defect is less than 50 millimeters and the depth of the defect is less than 10 millimeters, then the minimum action that would be taken by the inspector would be just to monitor the crack. However, if either of these two values are exceeded, so for example, their length is greater than 50 millimeters, then the inspector would have to apply a range of minimum actions. And this could vary from simply retesting all the way to more urgent actions, such as the complete removal of the track within 24 hours. So now that we have an understanding of the background, what is a squat defect? When I first heard of squat defect, the first thought that came to my mind was this: Sunday squatting. And I'm sure it came to many of your minds. And if it did, you would actually not be too far off. Here's an image of a squat defect. And what we can see here are two distinct lobes. And this is caused by the depreciation of the railhead. And when it was first found in the 1960s on the West Coast Main Line, it was remarked that it looked as if a heavy gnome had squatted on the railhead. And thus the name squat defect was born. Delving further into the history of squat defects, I found that there were two distinct periods of time where research took place, and they both yielded two different observations. The first period, which I termed the classical squat, took place between the 1970s and the 1990s, and they primarily focused on conventional railway in the UK and also in Japan on the Shinkansen. The second period, which I termed the modern squat, occurred at the turn of the century and was primarily focused on metros in the UK and also heavy haul lines in Australia. So some of the conclusions found from the classical squat research were as follows. They found that the squat defect initiated from the heavily sheared surface layer of the rail, and it was caused due to rolling contact fatigue. This heavily sheared surface layer was caused by the high shear stresses at the wheel-rail interface. As tonnage increased, the squat defect will propagate at a shallow angle of around 20 to 30 degrees for tens of millimeters, before eventually branching into the rail and leading to a rail break. Another important observation during this period was that a lubricant was essential for crack growth, and this explained why, for example, in Japan on the Shinkansen, squat defects were found almost exclusively in open areas, where water would enter the crack, and as a train went over, would provide higher shear stresses at the crack tip, aiding in the propagation of that squat defect. So here's an image of a cross-section of a rail, and what we can see is that the classical squat initiates at the surface, and there's a prominent leading branch and a less prominent trailing branch, and they both propagate at a shallow angle of around 20 to 30 degrees. And this branch would the leading branch would eventually propagate down into the rail and lead to a rail break. The modern squat theory found a squat that had similar characteristics to that of a classical squat. However, there were some fundamental differences. The first fundamental difference was that a modern squat was found to develop without severe plastic deformation at the surface, and rather it developed from something called the white etching layer, and I'm going to talk about this in a few more slides. The second fundamental difference that was found was that the defect had not led to a rail break to date, and this was in stark contrast to that of a classical squat. And again, here's a cross-section of the modern squat. But what we see this time is that the initiation occurs subsurface as opposed to on the surface as a classical squat. However, what we do notice is that the propagation mechanism is similar in terms of propagating at a shallow angle. However, it's important to note that a modern squat propagates at a much slower rate than that of a classical squat. So what is this white etching layer? The white etching layer is the difference between a classical squat and a modern squat. It is a hard and brittle layer on the surface of the rail, and it is due to its brittle nature that provides it the perfect initiation site for a squat defect. A very interesting thing to note that I found in the literature was that it says that it's a martensitic product. This means that the rail steel would have to have undergone a thermal phase transformation. For this to occur, the rail steel would have to experience extremely high temperatures for it to exceed the austenization temperature. This would cause the crystal structure to turn to austenite, and then through a rapid cooling process such as convection, produce this martensitic white etching layer. How this happens in the literature, there's a lot of debate. However, for the purpose of London Underground, the most prominent theory is that it is caused due to wheel slip. So having looked at all the literature, I produced this squat development process, which describes the differences between a classical squat and a modern squat, with particular reference to the initiation and propagation mechanisms. As we mentioned earlier, a classical squat initiates at the highly sheared surface layer and propagates due to fluid entrapment, eventually leading to transverse failure. The modern squat, however, initiates due to a white etching layer, which is thought to be produced through controlled wheel slip. Interestingly enough, the propagation mechanism of a modern squat is not actually known. But what we do know is that there is minimal growth, and to date, it has not led to a rail break. So what does this mean for us on the underground? After looking at the literature, I went through the track defect database, and this is a database that has the history of all defects found on track for the last decade and more. I found two very interesting observations. The first, that squats on our network have not actually led to a rail break to date in and of itself. The second observation was that they were more prevalent on Central and Jubilee lines. After doing some research, I found that the reasons for this could be that they both employ an aggressive ATO system, or automatic train operation system, along with wheel slip protection. And in areas with low adhesion, this could mean the perfect initiation site for the production of the white etching layer. So to conclude, I produced a report for the track technical team, and it concluded that squats on our network seem to align more with the modern squat theory. The consequence of this is that there is potential to challenge the minimum threshold values in our inspection standards. Looking forward, this means that we could produce more effective inspection procedures, which could eventually save Transport for London time and money. So that was a quick whistle-stop tour of squat defects. I hope you found it interesting. Thank you for listening, and I would like to open the chat to any questions. Thank you.
Thank you very much, Fahad. Let's get straight on. Excellent presentation, by the way. Sorry, fascinating there. Questions from the judges, please.
Yes, I've got a question there. You're mentioning the ATO as a possible cause, or the aggressive ATO as a possible causing factor. If we varied the ATO behavior more or less randomly, do you think that would be a useful thing for the squat defects?
Yes, I think so. I think so. The literature tends to suggest that on approach to signals where, or just after signals where traction effort could be higher, that this could be a reason for the squat development occurring. So if this process was changed, it could potentially mean less chance of reaching that austenization temperature, and therefore less chance of the white etching layer being formed, and as a consequence, less chance of squat development occurring.
Hi, Fahad. Kuldeep here. Great presentation. Thank you.
Thank you.
You mentioned Jubilee and Northern lines in terms of the ATO implementation. Yep. Is there any data giving us any evidence potentially from the Victoria line or any other lines that maybe have that?
So that's actually a very good question. So this is one of the questions that came up when I was going through this. And what I found was that as the Victoria line is completely underground, the conditions needed to achieve austenization never actually occur, because one of the conditions is a lower adhesion level due to, for example, being in the open where a low adhesion level could be caused by the weather. This is not actually an issue on the Victoria line. So we do not actually get much squat defects appearing on the Victoria line.
Okay. Thank you.
Okay.
Okay, do anything more from the judges?
No, I'll leave that to the audience, give them a bit more time to ask some questions. But thank you. That was a great presentation, Pat.
Thank you.
Okay, so the first one from the audience, Mark Molyneux. Can you get modern squats and classical squats on the same type of rail steel?
Sorry, can you repeat that question?
Yeah, sorry. Can you get modern squats and classical squats on the same type of rail steel?
Yes, from my research it's possible. So the classical squat, as I mentioned, is a rolling contact fatigue. So, and there is literature that suggests that a white etching layer could also be the cause of a classical squat. However, it's not as prominent as with the case with a modern squat.
Okay, thank you. Another one from Matthew Hack. Will there be an opportunity to take sections through defects found on London Underground to support your theory?
Yes. So one of the papers that I referenced quite heavily when doing the research was done by someone called Stephen Grassi, and what he did was he managed to get hold of samples quite a while ago, and he looked through the samples and took results that showed that white etching layer actually appeared on the London Underground network.
Okay, thank you very much. I can't see any other questions at the moment. Oh, I think there is one there actually. Let me just move. Sorry, Andy Batters. What is the main inspection detection method for squats? For example, ultrasonic, and could your research lead to more focused, targeted inspection?
So at the moment, the main inspection method is ultrasonic inspection. But what I found when I went for an ultrasonic inspection one night was that there is limitations to it, because one of the things that I found with squat defects is if it grows for a substantial period of time over the rail, then there's potential for it to mask further defects underneath the crack. But yes, the main inspection method at the moment is ultrasonic.
Okay, I'll just see if there's ones. Okay, so no more questions from here. Thank you very much, Fahad, for your presentation there. That's all for the presentation. So I just want to thank everyone for their presentations, and excellent presentations from everyone. We're going to go on to now a presentation from the outgoing chair of the IMechE Railway Division, Graham Neal.
Good evening, everybody. Hopefully, Emma will put the slides up. I'm just waiting for them to come up. Okay, right. As I said, good evening. So, as outgoing chair, it's my duty to give a summary of the annual general meeting report, which is being finalised as we speak and will be published after this meeting. So we'll just go through the process. So I'm just going to work out how to make the. That's better. Okay, so we're going to cover this evening very quickly. I think we've got about 20 minutes. I think we're aiming for. If Stuart can confirm that, that'll be good. I'll go through the last minutes of the meeting, which was held One Birdcage Walk on the 13th of May, 2018. And ask me why it's 2 years out of sequence, but it is, because this is the sign off of those minutes from last year, which were for the year before that, potentially. I'll give a quick summary of the annual report for this year. I'll describe the election of the Railway Division. The elections have just been held, and I will close the meeting and pass you all back to the final future rail competition so that the finalists can be announced. I'm still having trouble with the mouse. That's it. No, wrong one. Apologies. Okay, so these are the minutes for the last meeting. And normally, if we were in the One Birdcage Walk, the question would be asked if there's any objections, corrections, or amendments. We can't do that, and the minutes are yet to be issued. So just ceremonially, or ceremonially, I should say, I will. It's not working. Okay, we will have to duly sign those at an appropriate time when we ensure there is no queries. There's something going wrong here because my animations aren't working. I know they work for everybody else. Right. My apologies, everybody. I don't know why, but the animations aren't working on my screen. Stuart, do we know why the animations aren't working?
I think there was, for the animations, they won't work on WebEx because of the way it's done. So you might have to be able to skip to the full slide. Can you do that, or does it not bring them out?
I have no idea. What I can do is I've got the same presentation on my other screen. I can share my content if that works.
Yeah, Emma. Hopefully Emma can help us.
Yep, you can do that, Graham. You can share your screen. There's a button on the bottom of your screen that should allow you to do that.
Let's see if this works.
Yeah, perfect.
Okay, right. So did that change the slide? Did that work? Just to confirm. So you should be seeing slide 2 now with the agenda. Okay, so I'll crack on. So normally we would do the minutes of the meeting, which is shown here. If there are no objections or corrections or amendments, we will duly sign them and just ceremonially sign them on this particular presentation. So we'll move ahead. So it's usual for the chairman to do a quick introduction. In my case, I just wanted to say a few things before we get into the main report. And that is, at the beginning of the year, things were looking up. There were lots of things going on. There were we'd been through some rough times, but actually things were starting to look up a bit more. And my predecessor, Andy Mellor, said, you should have a much easier time, Graham. I wish to God he hadn't said that. We were looking at the introduction of electrification and decarbonisation on the railway. So there were things coming our way, which we were very happily preparing events for, to discuss and to share experience on. New trains were being introduced, and you can see some example, or an example here on the whole trains. Some of them looking very sleek and nice, not quite like our underground trains, but very nice looking trains nevertheless. And we were suffering a bit of a shortage of rolling stock engineers, so they were quite hard to find. So hopefully that's a good representation of that, and May doesn't object to me using a photograph of her. And Brexit was looming. Brexit was the one sort of thing on the forecast, which was a bit of an unknown to everybody. Nobody quite knew how it would affect the country, people themselves, the industry, and the supply chain. And we again made sure that in our events during the year that we covered this, and it was covered quite well by Dale Capling when we did his lecture in February, if I remember correctly. And then came along this little monster, COVID-19, and has upset everything for the last 3 months, so we'll come to that a bit later. So that's the same thing in words, just in case the animation didn't work, but luckily it did. So now I'll summarise the key contents of the Railway Division's annual general meeting report. Like I said, copies will be made available after the event. One of the good news is that engagement with the wider membership has once again increased. It increases, and you can see the figures from 2018, 2019, and 2019, 2020 there. And you can see that roughly they've gone up about between 1% and 2% per year, and it's still increasing. So engagement is improving. Nothing fantastic, but it's a good steady growth. The young members' activities also increased. We took a very positive step to invite young members along to more of the internal Railway Division committees, the events committee, comms, prizes and awards, which is already well covered. Obviously the Railway Challenge and the Railway Technical Tour. And in general, I think the Railway Division young members' activities within the division and their supporting and voluntary work has improved significantly. Nowadays, approximately a third of our events each year are organised by the Railway Division young members themselves, and they're actively involved in the strategic planning and hosting of the Railway Challenge and volunteering at the event in quite large numbers. They do maintain a collaborative relationship with the regional centres through the young member centre representatives, and there are long-standing members in those areas, but also those starting out in their careers. So I think the young members deserve some recognition for all the work they're doing. And they do also maintain a collaborative relationship with other professional engineering institutions and the young rail professionals. And a bit more on that later. But they did, for instance, young members have been jointly cooperating with the YRP on the young members tours, which will come up as well, the young rail tours. So they created a program to support the expansion of the Stapleford site, and they co-founded this Young Rail Tours initiative and went to Japan in March, just before the lockdown came along, so they were extremely lucky there. Early 2020 saw some changes in the Young Members Committee membership, with new members joining from across the country and a few changes there. But all of that is active, encouragement, more people getting involved. It's really good stuff. The Young Rail Tours emblem. The key headquarters events we held during the year were looking at technologies to streamline and optimise railway supply chains, rail electrification. We looked at new trains from CAF. There was a young members evening, the Future of Rail competition, very similar to this one. The chairman's address, which I took around the country, and the young members Christmas technical tour amongst some of the main highlights. These things attracted a total of 608 delegates. There were also 4 seminars and a conference on ATO, rail electrification, improving new train introduction. That replaced the Rail Accident Investigation Conference, and as did driver and pilot awareness, which was a joint effort between ourselves, the road and the air safety group within the IMechE. That replaced digital trains. And of course, the Young Engineers and Apprentices Railway Seminar, which again was very successful. Those totaling a total of 260 delegates. Not to leave the centres out, the centres have done extremely well this year. You'll see there's some strange figures there because a number of events, not too many luckily, but there were 8 centre events that were cancelled because of the COVID-19 lockdown. And the figures there show, in bold, they show this year's figures compared to last year's. You'll see there was a slight reduction in total attendance across the centres. But if you took the average attendance per event and added that back onto those centres that missed a few of their events, the predicted outcome would be somewhere around 15% better than last year. So I think it shows, despite COVID, the centres have done extremely well this year. So attendance is very good. Fortunately, our main annual luncheon, which we hold each year at the Grosvenor House Hotel at Park Lane, we managed to get that in just before the lockdown occurred, and that was very, very successful. It was a resounding success. We had 1,246 attendees, and we had generous sponsorship from those companies listed: Edis, Arapac, Clementech, Enatrek, Fraser Nash, Hitachi Rail, IE People, Milwaukee Composites, and WSP. My thanks go to all those organisations which supported us with their sponsorship. We had Mark Wild, the CEO of Crossrail, give a very thought-provoking after-dinner speech describing his early experiences with Crossrail and the difficulties of turning a large construction project into a working railway, difficulties which he's still grappling with. And a significant sum was raised for this year's chosen charity, the Railway Mission, which offers support to railway staff, British Transport Police, and the travelling public, people of all faiths and people with none. And that was a good turnout as well. It's Mark Wild, for those who weren't at the luncheon. The Railway Challenge was held as usual last year at Stapleford Miniature Railway. Was again hugely successful with 14 teams participating, and very entertaining for the spectators with their performances and occasional failures in the various challenges. Winners for the first time with a truly impressive overall performance, including wins in 3 of the individual categories, were Aachen University from Germany. Runners-up were Transport for London. That was my team, so I'm pretty proud of that, closely followed by Ricardo Rail. The Aachen team captain, Robin Mulmeyer, said, "We are participating now for the 3rd time in the Railway Challenge and continue to make progress each year. This time it was enough for us to take the trophy back with us. It's always an incredible pleasure to be here at Stapleford Miniature Rail." quite a nice statement from them. And the judges also gave a discretionary award to Poznan University for innovation and elegance in mechanical design in respect of their composite bogie frame and leaf spring bogie as well. And I think many of the teams that entered for this year's challenge, but which we've had to temporarily postpone to next year at the fair, I think it gives them a bit more time to work on their vehicles and their reliability. So I'm expecting some really good results next year, and I hope that expectation arises. The Railway Technical Tour was also very successful last year. We went on a tour around. We started in Prague, so we started Czech Republic, and we visited Austria and Switzerland, finishing our tour in Zurich. We visited various railway premises with an average of 2 visits per day. 40 people attended, lots of train travel by both national and private operators, and from most participants, we even travelled on a sleeper train overnight. Not something that I've done many times before, and it was what I would call quite cosy. Highlights included visits to one of the biggest traction motor manufacturers in Europe, some roller stock manufacturers, a software house that specialises in railway applications, and especially popular, a ride on a beer tram with an open bar. That was a very warm day as well, so it was very well appreciated. And thanks to Felix Schmidt and his team of organisers and sponsors and hosts for a very valuable opportunity to experience different types of operations, see new ways of working, and strengthen our personal and social networks. There was an article in I think it was in the Rail Engineer, that said it's Tuesday, so it must be Olomouc. And Olomouc was one of the places we visited, and there's a picture of us waiting for our train on the station. Financially, we did quite well as well. We started in 2019 with a bid to the IMechE to become an IMechE cost centre. We felt as a rail division board that we could demonstrate financial stability and try to use the IMechE funds that we gain both from the annual luncheon and elsewhere in a more effective way than had been done in the past, and we were granted the opportunity to do that. But by the time we were granted that opportunity, it was June, and at that point we were predicting a £6,000 loss. The good news is we turned that into a £16,000 surplus at the end of the year, and that's been transferred into this budget. We've already used some of that to support young members at the annual luncheon and a few other things, the annual young members tours as well. So in itself, it was a major accomplishment, turning that deficit around and turning it into a surplus. And the 8 railway division centres themselves have also delivered their extensive programmes of events within their allocated budget. We purposely ring-fenced, or equivalently ring-fenced, the allocated budgets for the centres, so they were effectively protected in this first year while we did our cost centre experiment. The Railway Industry Skill Challenge is another activity that the members of the board get involved in. We have a Railway Division Skills Task Force, which continues to support the rolling stock engineering skills agenda and includes representations from the institution, the board, and members of the Railway Division. The initiatives for promotion of engineering as a career and introduction of new standards of funding for apprenticeships have continued. We're still trying to close the skills gap. We're working with the Design and Technology Association to promote teachers in residence, a scheme to put teachers in industry and raise their awareness of modern working environment. We're also investigating whether there are opportunities to promote the primary engineer rail project aimed at raising awareness of railway engineering in primary schools, with 2 large railway industry employers already supporting the scheme. The composition of the board is on the agenda. We asked if there are any nominations. We had nominations from the board, but there were no further nominations were received other than the 3 candidates. Their names will be in the minutes and were put forward by the board. and 3 ordinary member vacancies were therefore deemed elected unopposed. I'm delighted to announce that the Railway Division Chair for 2020 to 2021 will be a very good friend on this call, Emeritus Professor Felix Schmidt from the University of Birmingham, and there will be a brief summary of Felix's career and railway-related accomplishments in the full AGM report. So congratulations, Felix. And at some point, we must arrange for transfer of the IMechE Railway Division gong to you so that you can formally wear it. During his year as chair, he will engage with the RD centres and headquarters to offer a robust programme of events, including at least one jointly with a number of other PEIs, which we're planning for the autumn this year. And despite the continued uncertainty around the ability to hold in-person events, Felix is aiming to add a whole system focus with a strong emphasis on the people in the system. The Deputy Chair for 2021 will be James Collinson from Network Rail, who currently manages our finances and has done very well on behalf of the Railway Division Board. In my Chairman's address, all change and mind the gaps last year, I described what I saw as the key gaps facing the railway industry, namely the skills gap, Brexit, the economic gap, the technology gap, and the IMechE industry gap. Many of these gaps do still exist, and changes are still necessary for our industry to bridge those gaps and to develop and thrive. And like my predecessor, RD chairs, I call on Felix to take up the mantle and continue the good work of the Railway Division in addressing those gaps and challenges. I also set myself 4 objectives to improve learning society engagement, which, as you can see, we've done. Increase the railway industry support, and that actually happened at the Railway Challenge. We got more sponsorship than we've had in previous years, at the annual luncheon, and at the Railway Challenge. Broadening railway engineering skills, which you've seen some of the activities we're involved in, and also sponsoring the RD as a profit centre, which we've successfully done for the first year. So finally, my very heartfelt thanks to all who have supported me in my year of office as RD Chair, especially you, the division members, the RD Board members, past chairs, committee members, young members and other volunteers, the RD centres, their committees, members and volunteers, all of the speakers who gave their time and effort to engage with our members and to share their knowledge and experiences, and all of the railway industry organisations, companies and sponsors who support our learning society activities. And finally, to the IMechE support staff who work tirelessly to support us in delivering our programmes and activities. And I thank you all for listening and hope that I haven't overrun too much and that's given our judges enough time to carry on with their or to deliver their deliberations and see who's won this fantastic competition. Back over to you, Stuart.
Thank you very much, Graham. Yeah, thanks for the roundup there. Very, very informative and interesting. We're just going to go quickly to Paul Burkitt-Gray, who's going to give us a rundown on IMechE events.
Yep.
There we go. That's me unmuted. Fantastic. Thank you. Good evening, everybody. I'm Paul, Vice Chair of one of the Vice Chairs of the IMechE Rail Division Young Members. So a couple of upcoming events that we have for you in the next, few days. We have tomorrow the 2020 Railway Challenge, as mentioned by Graham, has for its main event at Stapleford Miniature Railway been postponed until next year, but we will have tomorrow afternoon at 12:30 a virtual presentation and awards ceremony, which will be conducted just on the kind of written and design parts of the team's entries. And I'm just going to paste into the chat box there a link if you'd like to sign up to that, and you'll be able to register to watch that tomorrow afternoon. We also have coming up in July, Rail Trail 2020. The Rail Trail is normally our scavenger hunt around central London, railway themes, going around different railway related locations, solving all sorts of clues. This year we're going to be for the first time holding it virtually on Thursday the 23rd of July, and because it's virtual we won't be geographically constrained by London. We will be able to extend all over the entire world railway, so there'll be lots of fun clues to solve there and a prize for the winning team of up to 4. and you can sign up for that in another link that I will just post into the chat there if you would like to have a go. We'll also have coming up in October the Young Engineers and Apprentices Railway Seminar event. That will also be held virtually this year. It's a bit of a event to introduce new entrants to the railway industry, to what's going on. And this year we're really going to be asking the big question of what happens next for young engineers at a time that is very uncertain in the railway industry with a lot of change. And then finally, we do have a full programme of webinars going on presented by several of the regional centres, 3 of them listed there. And if you do a search for upcoming events on the IMechE website, you'll see all of those available to be signed up for. So that is what we have coming next.
Excellent. Thank you very much, Paul. Some interesting events coming up there, so let's get signed up for those. I've been told that the judges have come to a decision, so I'm going to hand you over now to the head judge, Felix Schmidt.
Good evening, everybody, and thank you very much for attending this event, because it's been properly supported. I think there's been a lot of very interesting information transmitted. Everybody has learned something, I hope. I certainly did. And I think all the presentations were excellent in their own ways. And so the judges had to do a fairly hard job. We each had our own set of criteria. We haven't gone sort of for a common set of criteria, which would have made the job far too easy. But I think we've come up with a set of 3 people who we felt contributed most to this event. At least in our perception. You may all have different views. So if you want to have your own views, then just put them into the chat. But we, as a tradition, I shall start with the 3rd placed presenter, and that's Amy MacDonald. Now, a very interesting presentation on her new challenges, and particularly the Mark 5's new sleeper trains. And I think her final comment, no, these trains are not going to be as reliable as what they replace, was very telling. And so David sort of called it the most entertaining presentation, and I think I agree with that. That's not a criterion, but it's certainly a very good way of gaining favor with judges. Something which is entertaining and at the same time useful. In place 2, we had Amanda Sultan about the central pivot bush, a very, very technical presentation about some very interesting and tough measurements and mathematics to actually plan the measurements and mathematics to evaluate the results. So Amanda is in place 2, and she was my favorite because I like techie things, but we decided amongst us that she should be a very, very highly rated 2nd placed person. Finally, you're of course all waiting who we put first, and so I have to build up a little bit of tension on this. And I'm going to say, first of all, that what Kuldip said about it, it's the most educational talk. Everybody who goes away from this event will now know what is a squat, how it develops, where the problems are, and that it's the original expression comes from a dwarf sitting on the rails and putting his bum imprints on it. So Fard had a very, very clear and simple presentation, and that's a skill as well, where not a lot was on each side. He spoke very sensibly at a reasonable pace, and I think everybody at the end knows what a squat is. So we felt that he was definitely number 1. So I think that's all I've got to say on behalf of the judges. I'd like to thank the judges. I'd like to thank Stuart for chairing the whole event. Mayan for managing a lot of it, Graham for filling the gap, and everybody else who was here, and Paul as well, and everybody who was here for enjoying the evening, we think. Okay, so thank you very much, and I hope to see you at many more virtual and hopefully real events. And all the presenters have done an excellent job, and we must remember that they all won a heat, and they all, I think, got a prize for the heat. So don't think that they're walking away with nothing. So thank you, and I think I'm declaring this event closed unless Mayan or Stuart want to make any final comments.
I'll just echo what Felix said. Again, all the presentations had won their respective heats to get through to the final. So I think that was shown in the quality of the presentations that we had here tonight. So firstly, I just want to thank all the presenters and the finalists for giving up their time and presenting tonight. I want to thank everyone else who joined us to watch the presentations tonight. Your questions as well. We had some fantastic questions from you people, and just my only apology is that we couldn't ask them all out, and there were occasions where there wasn't room for questions, but so be it. Again, thank you for the judges, and thank you for Felix for leading the judges. I think we can't really argue with the decisions, so well made decisions there. Thank you to Graham as well and Paul for doing their talks and keeping us entertained whilst the judges deliberated. And I also want to thank Emma for arranging the evening and controlling the WebEx, sorting the slides out, and technically basically being on top of the game. So on that note, thanks to everyone, congratulations to the winners, and we'll see you again soon. Thank you.